Right, we are 1 minute to launch. We're live at the European Spaceport in French Guiana for the launch of Sentinel-2C. Our very best wishes to all the teams.
Go Sentinel-2C.
They're off. Sentinel-2C and Vega are blazing a trail across the equatorial skies here over Europe's Spaceport in French Guiana, heading north out over the Atlantic towards the Caribbean islands, burning the first 3 stages. The first stage, of course, burning now, getting us away from the gravity of the Earth. Vega really shoots into the sky, Damien, doesn't she?
Yeah, it does, and we could feel the rumble-tumble here in the commentary cabin. So the P-80 delivers a powerful thrust about 230 tons, equivalent to twice its weight. It just results in a very rapid acceleration. So the first stage, its mass in propellants is 89 tons, and it is made of a special material called filament wound carbon epoxy.
And we're looking here at fantastic images and separation there of the P-80 first stage and switch on of the second stage, the Z23. So at this point in time, we've lost about 2/3 of our weight. And we're hearing that the propulsion is nominal. And the trajectory is nominal. And of course, the idea is to get rid of mass when it's no longer needed.
As soon as each solid stage has used its propellant, yes, we jettison it. So that's why we split a rocket into different stages to avoid dragging unnecessary mass into space.
And we're burning the Z23 second stage, Z for Zafiro, which is a type of wind, a gentle and favorable west wind.
It is often associated with bringing speed and good weather. It very much aligns with the goal of the Vega launcher, which aims at providing reliable and efficient access to space. So, Katie, it's a poetic note to the idea of a smooth and successful journey.
And the fairing at the front of the rocket there, you can see Sentinel-2C inside. And we're getting news there that coming towards the end of the burning of the Z23. Our altitude there on the top right-hand side, 113 kilometers above the Earth, and bottom, the vitesse is our speed, traveling at nearly 4 kilometers per second. Separation there of the second stage, and there's a short delay before we then get the ignition of the third stage. That's to avoid any collisions up in space.
Absolutely. So
And we have separation now of the fairing that's been jettisoned. We don't need it anymore. And if you look at the altitude, we're 130 kilometers above Earth. We're hearing that the propulsion is nominal, and so is the trajectory, everything going according to plan. And we can see Sentinel-2C, Damien, for the first time. It's that gold structure at the front.
yes, so we can see the 3.4-meter long satellite attached to the AVUM upper stage. So the gold part is a thermal insulation. It was specifically designed in the 50s to protect satellites from the extreme temperatures in space. And since then, it has been developed for all kinds of uses here on Earth. That includes emergency blankets, like the one you might have in your car.
Well, I don't actually have one in my car, but I know the ones you mean. They're very crinkly and noisy. And you can see there we've lifted off from the Guiana Space Center. The Galileo was the tracking station here, and now we're using Saint-Jean-du-Maroni. And if you look at the picture there, you can see there's just one solar panel today.
Yes, it is to maximize reliability and efficiency while meeting the satellite's power requirements. So satellites must be as lightweight as possible, as you know, and every kilo counts, every little helps. And so know the speed should go just a bit under 8 kilometers per second, so we are heading toward that.
And everything is going according to plan. Everything is nominal. These images on the right-hand side are the computer-generated images. They're kind of a 3D animation of what's been planned right now in space, and they're pretty well as close as we can get to real-time imagery, aren't they?
Yes, so our mission analysis teams plan a precise set of events, and we put that in a computer, and it shows us the behavior that they have predicted, that includes orientation with respect to the Earth and the Sun. We put a lot of effort into it to make it true to life. The satellite is modeled from 3D plans, obviously. For the textures of the different parts of the satellite, we use photos to try and reproduce how they really look like. For instance, the thermal insulation that we just mentioned.
And it's really useful to have those images because, of course, the problem with space is that it's in space, so you actually can't see what's happening. Getting close now to separation, there we go, of the third stage. That's been confirmed. And so we've got away from Earth in 6.5 minutes. This is the speed, of course, that we're traveling, 7.5 coming up to kilometers per second. So we can really start the next phase of the flight now, Damien. Our flight path takes us up north. We're heading up over the Caribbean towards the east coast of Canada. We're crossing the Arctic and back down over Southeast Asia to the west coast of Australia, and that's where we're going to be releasing our satellite. Why north?
So the satellite will be in a fixed position over the Earth, north to south, with the Earth rotating below it. Imagine, Katie, you're peeling an orange stripe by stripe.
I'm just going to stop you there. We've had confirmation of acquisition of signal at Bermuda. So yes, stripe by stripe.
Yes. The Sentinel-2s peel very wide stripes. Each swathe is nearly 300 kilometers, so they can image our entire planet in 5 days.
Amazing. And we've got the switch on time. Now this is the scheduled moment to switch on the engine of the AVUM upper stage. We have that confirmed. This is an important moment, actually, in the flight. Trajectory is nominal, we're hearing. We've really started the next phase now of this part of the journey because the AVUM or AVUM has taken the wheel and its job is to deliver our passenger to its required orbit.
Yes, it must be very precise. We must release Sentinel-2C on exactly the right injection orbit, nearly 800 kilometers altitude, with the correct inclination, which is 98.5 degrees. But first we have to get there, so the first AVUM boost is for reaching an intermediate elliptical orbit. After that stage, we'll cut off.
And AVUM means attitude and vernier upper module, bit of a mouthful.
Absolutely. So in engineering, a vernier is a precision tool. It refers to the precision required of the AVUM, which can deliver satellites at different orbits. So it needs to perform satellite fine pointing before separating it. That is why we need liquid propulsion. It allows for more precision maneuvers than powder, because powder is more suited to provide raw power.
Indeed. One of the features of the AVUM upper stage is that it can actually restart its engine. And for Vega, the first generation model, this one that we're using today, that's up to 5 times. But for Vega C, it's even more, isn't it? And I know this is important, but just can you explain to people why?
It allows the AVUM to deploy different payloads into separate orbits, much like an elevator, stopping at multiple floors. It's a big advantage of the Vega series. Not all launchers can actually reignite their upper stage. So today there is only one separation for one customer, but for some launches, it's common to adjust the orbit between 2 or more separations. So Vega C has the impressive ability to reignite its engine up to 8 times. This allows us to reach up to 3 different orbits with Vega C.
And that's very, very important when you've got different passengers wanting to get off the bus at different bus stops. So here we are 10 minutes into our flight. We are 310 kilometers high. We've traveled nearly 3,000 kilometers across the planet if you were to draw a straight line along the Earth. And our speed nearly... oh. You'll have to excuse me, folks. I've got a bit of a cough.
Yeah, so basically we will be now picking up the signal in Gatineau in Quebec, Canada in about just a few seconds. We are waiting for confirmation.
Indeed, and if we look at the left-hand side of our screen, we can see the planned flight path with the white cross is the actual position of the rocket.
So we just acquired Gatineau. Hello, Gatineau.
Hello, ladies and gentlemen, boys and girls in Gatineau in Canada.
So the speed is roughly 7.5 kilometers per second. That's the equivalent of 27,000 kilometers.
And we're looking here at the teams at the CVI.
Yes, absolutely. So they are based on the Montagne des Pères. It's on a hill just a few kilometers away from us. So the Quick Look Telemetry, or CVE in French, team, they depict the current status and any significant findings from the telemetry data. The steps ensure that everyone involved understands the situation and potential issues. They pass on the info to the Range Operations Manager, the DDO, in the Mission Control Room. And the Range Operations Manager is responsible for announcing the confirmation of major events such as stage separations, engine cutoff, and successful payload deployments.
So they're doing very, very important work there.
Absolutely, and everything is still nominal.
Now, you might have noticed the logo for the city of Sevilla in Spain on the fairing of the rocket, and that's because this year Seville has taken over the presidency of the Ariane 2024 community of cities in partnership with Airbus Defence and Space. It was set up in 1998 to strengthen cooperation between people involved in the space industry. Let's hear now from the mayor of Seville, José Luis Sanz.
En 2024, la ciudad de Sevilla suma la presidencia de la red de ciudades Ariane, formada por cerca de 20 ciudades y otras asociaciones empresariales europeas vinculadas a la industria aeroespacial. Sevilla se convierte en la capital espacial europea. Hoy somos un referente siendo uno de los principales hubs del sector aeroespacial europeo, epicentro de la industria espacial en España. Y para su celebración, Sevilla está desarrollando un amplio y diverso programa de actividades técnicas, culturales y educativas. Este gran programa es fruto de la colaboración público-privada y con la estrecha cooperación de Airbus, nuestro partner en la presidencia, pilar fundamental de la industria espacial nacional. Además, está involucrado todo el sector aeroespacial sevillano, junto con otras entidades públicas y privadas, miembros del Foro del Espacio, que representa una importante industria con más de un siglo de existencia y consolidada, con compañías representativas como pueden ser Alter Technology, SolarMens o Catec. Es todo un honor que bajo nuestra presidencia de Ciudades Ariane se celebre el vuelo inaugural del Ariane 6 en el Puerto Espacial Europeo de Kourou, en la Guiana francesa, símbolo del posicionamiento e influencia del sector espacial en Europa. Este proyecto servirá para atraer inversiones a Sevilla, para proyectar internacionalmente su tejido empresarial y para captar fondos de proyectos europeos. También nos ayudará a difundir entre los sevillanos los beneficios que reporta la actividad espacial para Sevilla y nos ayudará a posicionar a la ciudad como la gran ciudad tecnológica e innovadora del sur de Europa. Desde Sevilla, capital espacial europea, nuestros mejores deseos para Arianespace, porque sus éxitos serán buenos para Sevilla, para España y para toda Europa. Muchas gracias.
So that was hearing there from the Mayor of Seville. It was great to hear from him. And just a quick word to let you know that we seem to be having a few difficulties actually hearing the Range Operations Manager today. But Damien and I are receiving the information directly from the CVI, who are getting the telemetry from the tracking station. So we're giving you our confirmations that way, and Damien is able to confirm things.
Absolutely.
Back to our satellite, it's an important one. Our world is changing, the climate is warming, the population is increasing, and cities are expanding, and some of the biggest challenges are meeting the growing demand for food and water, keeping people safe, and forming strategies to address climate change. And looking down from space is vital for planning a sustainable future, which is why Copernicus, along with Europe's satellite positioning system Galileo, are key components of the European Union's space programme. Damien, let's just talk a little bit now about some of the applications for the information from the Sentinel-2 satellites.
Yes, so we talked earlier about how important the Sentinel-2s are in giving new insights into the world's vegetation that's important for land use and food production, for instance. Say you are a farmer, you might use satellite data to decide how much water or fertilizer to use. It can also be very much useful in planning how to respond in emergency, such as floods or volcanic eruptions. So, for example, you might remember the fires in Greece this summer. We can actually see them on the screen. The wildfire near Athens. So a massive one erupted on August 12th. And this Sentinel-2 image shows it. So you see, it uses a natural color combined with shortwave infrared to highlight the active fire fronts in red and the burnt areas in dark brown. The fire, driven by strong winds, produced a smoke cloud extending over 300 kilometers towards Libya, covering parts of Athens.
Absolutely terrifying. The Sentinel-2s can also help manage water resources, as we mentioned earlier, and not just for drinking, but also for agriculture, energy and sanitation. And that's because they can measure the health and changes to water bodies, and that's whether they're lakes, inland, for example, or on the coast.
Mm-hmm. Yeah, you can see here some coral bleaching in Florida. So in July 2023, just a year ago, record high sea temperatures were recorded around Florida, and they soared more than 2 degrees Celsius above normal, causing widespread coral bleaching in the Florida Keys. So this Sentinel-2 image shows the affected area near Isla Morada. Thanks to data from Copernicus, scientists can monitor these rising temperatures and their impact on the oceans.
And we're hearing there that all the parameters are normal. Interestingly, the Sentinel-2 can also help in predicting malaria outbreaks, but it can also help us understand animal populations.
Yeah, you will never guess what's the last image. It's a penguin colony discovered in Antarctica. So the Sentinel-2 satellites, with a resolution of 10 meters per pixel, offers a detailed view of our planet, leading to discoveries like these new penguin colonies. So it's an image from November 2016, a colony near Cape Gates, Antarctica. And it was not detected, funnily enough, by the penguins themselves, but by the large brown dropping stains, also called guano, that they left on the ice. So it helped scientists track these populations.
Who'd have known that penguin poo would be so useful? Coming up to the next phase now, Damien.
Yeah. Absolutely. So you can see we just switched off the engine now.
That's coming up at 18:30. Here we go. That's what it looks like up there.
Yeah, and we've got confirmation.
We have confirmation, yeah, indeed. So why are we switching the engine off now?
So the AVOM has placed Sentinel-2C on an elliptical orbit, the shape of an oval, if you will, and now the altitude of the launcher is naturally rising. So when reaching the top, the maximal altitude of the elliptical orbit, the AVOM will reignite to circularize the orbit as at its final altitude.
Let's talk now about Space Team Europe. It's in a mission like this, it's always the result of years of teamwork across Europe, and relationships are made and friendships are made. Space Team Europe is an initiative led by the European Space Agency, and it aims to bring people working in the field of space under the same umbrella, with no barriers or boundaries between companies.
Dunque, essere responsabile di una campagna di lancio significa presiedere la pianificazione e la gestione operativa di tutte le attività di integrazione e di test del lanciatore, nonché tutte le attività di preparazione del lancio. Attività che toccano diverse discipline, diversi perimetri, come ad esempio quello meccanico, quello fluidico, quello elettrico, avionico, e quello che noi chiamiamo di parte alta, che è la parte superiore del lanciatore, quella che è in diretto contatto col satellite.
Oggi sono direttore di stabilimento di Avio Guiana a partire dal 1 agosto 2024. Avio Guiana è un'azienda che opera all'interno del CSG dal 2020 con la responsabilità di mantenere le infrastrutture del sito di lancio di Vega nella sua piena efficienza e di coordinare le integrazioni del lanciatore Vega e Vega C in sinergia con la casa madre.
Donc moi je fais du CVI, qui veut dire du contrôle visuel immédiat. Ce qui signifie qu'en temps réel, pendant la mission du lanceur, on va suivre un certain nombre de paramètres de ce lanceur, les analyser et fournir une synthèse de ces analyses vers le centre de contrôle à Jupiter pour le directeur des opérations, mais aussi pour la direction d'Arianespace, la direction du CNES, la direction du Prime Avio, et leur fournir les informations qui vont leur permettre de se rendre compte si le lanceur se comporte normalement.
The work of the program manager consists in managing the programs, in this case, in my case, the Vega-related programs, both development and exploitation accompaniment, along their lifetime. The lifetime of a program starts with the definition of the program proposal, the submission to the Ministerial Council. It is a matter to manage day by day the activities, to accompany the activities to their successful conclusion. Taking always in mind and respecting the programmatic objectives, which are cost, schedule, and performance and technical requirements.
Sono responsabile sicurezza ambiente e SOGGUARD. Mi occupo di prevenzione e di gestione in tempo reale dei rischi lavorativi. Il mio ruolo consiste nell'assicurare il rispetto della normativa, valutando i rischi connessi alle attività svolte, e di assicurare la protezione dell'ambiente, delle installazioni, ma soprattutto dei lavoratori. In più mi interfaccio con le autorità francesi e del centro spaziale.
We're going to take a short break now during this coasting phase and cut our microphones for just over 20 minutes. So we're going to keep the telemetry on the screen for you and the 3D animation. And we'll be back in about 23 minutes' time, just before separation of Sentinel-2C.
Yeah, so if I were you, I would stay tuned because the most important part is coming up.
It is indeed, the separation and releasing of our satellite. So we'll be back just before 11:40 here in Kourou. That's 3:40 in the morning, Greenwich Mean Time, and about 4:40 Central European Time. See you then.
separated on the targeted orbit. It is a full success tonight. This is the 5th Sentinel satellite we
seconds, and he's telling us that the orbit is completely nominal. We can see there, Damien,
Début de la manœuvre d'orientation au profit de Sentinel-2C.
Beginning of the orientation maneuver, getting Sentinel-2C ready to be released onto its orbit.
Yes, so the altitude is just where it needs to be. The speed is 7.6 kilometers per second, so it's the same speed as the ISS, roughly.
Séparation Sentinel-2C.
We have separation there of Sentinel-2C. That's good news. We are looking at happy faces in the Mission Control Center here, Jupiter Mission Control Center. That's excellent news. Here we are looking at the teams in the fishbowl, the operational teams.
Yeah, everyone happy in the flight cell and within the client parts as well.
Sentinel-2C on its way now, heading out on its own journey. We've delivered it to space, and now it's heading out to make its own life. And of course, the teams at the European Space Operations Centre and also at Airbus taking on their baby now and controlling the satellite as it goes through the early operations to commission it. Vega having done a good job there and lifted off, operated like clockwork.
Oh, definitely so.
Yes, everything went according to plan. So we're going to hopefully hear now from the CEO of Arianespace, Stefan Israel. Stefan, great to have you back with us. Thanks very much indeed for coming back to chat with us a second time. Good news, we've released the satellite.
Yes, it's an excellent news. We have perfectly completed the mission tonight. The satellite Sentinel-2C has been separated on the targeted orbit. It is a full success tonight. This is the 5th Sentinel satellite we deliver successfully, and I can tell you we are very grateful to our customers, the European Commission, ESA, to our partner Airbus, satellite manufacturer, to our prime Avio for this great success.
And what's next, Stefan?
Indeed, in fact, Vega is going to deliver one more time for Copernicus. It will be Vega C, so the next generation of Vega. And now with ESA, with Avio, we are going to prepare the return to flight of Vega C. And the return to flight of Vega C will be once again for a Copernicus satellite. It will be Sentinel-1C by the end of the year, so keep posted.
Absolutely, keep posted indeed. Stefan, thank you very much indeed.
Thank you. Thank you.
Well, now, we've talked a lot about our satellite, Sentinel-2C. Let's turn our attention now to the people who use the information which the Sentinel-2s provide. The Copernicus program currently has more than 750,000 registered users. That's 750,000 people who use the information coming from the satellite, and they can be anyone from farmers and environmentalists to emergency services and journalists just like me, receiving press releases in our inbox about the state of the climate, for example. And that information is completely free. It's a fantastic service and anybody can use it. And I have to tell you, I'm very, very impressed. But it's one thing receiving the data from the satellites. It's another thing being able to understand it and use it. And that's the job of the Copernicus program. And I'm absolutely delighted to introduce you to Uzwe Donizar, or Donizar, I think I should be pronouncing it with a better Spanish accent, who's joining us now. Uzwe, you are from the Copernicus Land Monitoring Program. You lead the Copernicus Land, let me just get this right, Copernicus Land Monitoring Service, which provides information about the land. And of course, Sentinel-2C is all about the land and the water. Just tell us a little bit more about, well, first of all, wonderful launch, eh?
Yeah, Yeah, that was a wonderful experience, I have to say. Yes.
Yeah, did you see it? Did you go outside and see it with your own eyes?
Yeah, I'm still trying to digest it.
Uswe, tell us a little bit about the kind of people who use... in a minute you can tell us about what you use the information from the satellite for, but tell us about the people generally who use the information.
So we have different types of users of Sentinel-2 data. We first have this type of people who actually know how to do how to produce information based on the satellite imagery, and that would be me, for instance, 20 years ago. And then we have those people, which is a wider public, that do not really know how to process the data and do not really know how to create information on them. And what we do on the Copernicus land monitoring services, we create information based on those satellite imagery, information on in our case, on the land cover, and also on the changes that are appearing on land, and also on biophysical parameters.
And what do you use that information for?
Well, we create different types of products. Maybe the easiest to imagine for a layman would be a digital map, so to speak, but that's far too simple. So what we are doing is, based on the satellite imagery, we analyze it, we analyze the time series of the images. We analyze a lot of images acquired one after the other, and what we infer from them is things like crop classification. We also make analysis of the tree cover density over a certain area, or we are monitoring inland water and the quality. Another one, which is I think one of the most intuitive, is to give you a kind of cartography of the land cover, so what can be visible on land.
And what does this information actually tell you? I mean, how important is it?
Well, it's really important in our case. So the land monitoring service, actually, it's co-led by two different entities. I am leading it at the European Environment Agency, and then the Joint Research Center is leading it at global level. So at the European Environment Agency, we are doing it only within Europe, and this is because one of our main goals is to serve different environmental policies. What we're trying to do, sometimes successfully, sometimes not so much, is to create information that can serve the policymakers to take decisions on how to protect better our environment.
Now, Sentinel-2C is replacing Sentinel-2A. For anybody who doesn't understand how satellites work in terms of providing continual information, can you explain why that's important and why we need to have two satellites in this particular configuration, and why it's important to replenish the constellation?
I think one of the biggest added values of Copernicus program is that it's a commitment towards consistency and coherence over time. So because we have a purpose in our case, which is serving the European policies, but it could be other purposes as well. In the case that you were mentioning before, the emergency management service, that's also quite a big purpose to be able to support the different administrations that are dealing with emergencies. It is important to know and to tell our clients, our stakeholders, okay, this is here and it's going to last, and we are going to continue it, and it's not just a proof of concept, so to speak. It is
Début de la manœuvre d'orientation avant le troisième boost à Voum.
We're hearing the range operations manager there, just confirming that the next orientation maneuver is beginning for the for the AVAM upper stage to perform its third boost, which of course will be part of its deorbiting program. So, just coming back to Sentinel-2C and the Sentinel-2s in general, I mean, what other projects or applications could benefit from Sentinel-2's data? Because I know obviously you guys are using it for your specific purposes, but there are quite a lot of other applications, and even some surprise ones, aren't there?
Yes, I mean, in fact, we are only doing, we are not doing all that could be done with the Sentinel-2 because it's maybe in some cases it's not our mandate. But I think that for the wider public, the possibilities are endless. I have to say I've been in the business almost for 20 years now, and when the Sentinels were launched, when we started receiving the images, the whole paradigm of how we work with the Earth observation changed. So we came from just using a single image, maybe two at most, that were actually taken up to 80% of the cost of the project. And now we have this whole time series to take advantage of it. So we could think about potentially monitoring of environmental crimes is one of the things that lately is starting to be really on top of really high in the agenda. We are already monitoring the status of the vegetation across whole Europe. Our colleagues at the Joint Research Center are creating now, for the first time, a land cover map at 10 meters for the whole globe, with a very, very high repeat time, so a very high update frequency. And all these things are only possible because Sentinel-2 is there for us.
It sounds like this is a very, very important mission for you, which is not just important for you, it's important for all of us on Earth. I wanted to ask you a little bit more about disaster management, because we heard earlier from Damien, was talking to us, showing us a few slides and some of the work that Sentinel-2s have been doing. How important is it for disaster management and making better decisions when dealing with emergencies?
Yeah, I mean, one of the biggest added values here is that we have an updated image every 5 days. So this gives a lot of very powerful information to the civil protections that are working in the field to see how is, for instance, a forest fire, how is it evolving. You can see it almost near real